This topic is actually very important because many of the questions that the student get in scholarship tests and a selective test require the understanding about sets. All right, so we'll start with the very basic question. What is a set? So, what is a set? A set is simply a group of objects that share some properties. Now, this is a really simple definition for a set. Now, let's look at one example. Now, in front of you, you see some objects. Now, what you get is just the information. Now, the next step we will do is to organize it. All right, so how are we going to group these objects? Let's try one way. All right, so what you have seen so far is I have grouped the objects into 4 sets. Now, the question is, can you work out how I group them? All right. Now, if you work out that I group by the color property, then you got it right. Now, there's so many ways you can group these objects. We'll try again. Now, I'm going to group using a different property. Now, I have 2 sets of objects. So can you work it out? What property did I use to do the grouping? Well, if you think I group by the line property, you got it right. Now, you see, in the second group down the bottom, you see the curves. So in the first set, you have only straight line segment. But in the second set, every single object has a curve in it. Now, let's try again. We will group using a different property. All right, so I have 2 sets. Now, look at them and see whether you can work out what kind of property did I use. All right. In this case, the group is by the dimension, your property. The first set is 2D, and the second set is 3D. All right, so you can see that grouping is an operation that is so basic and so essential. Now, in the world around us, how do we get to create knowledge about the world around us? Think. Actually, all we do is grouping. That is a very basic operation. That's the first thing you do. You observe the world around you and you group what you see. And that's what you do. And that is something that has been programmed into the human brain. That's what we do. All right. Let's have a bit of fun here. Now, imagine a scenario in the school playground, and there are two boys. You got John and Fred. And Fred is new to the school. And John said to him, as you are new here, I better warn you. See over there? That's a bunch of bullies, with Sam being the leader. You don't want to mess around with them. Oh, thanks. I'll keep that in mind, replied Fred. Okay, so this is a casual conversation between two boys, but buried under it, there's some information that we want to know. Now, so in the language of set theory, this is what inside it. There is a set or a group of bad boys in a school who share the property of bullying. All right. So John actually referred to a group of boys in the school who share certain property. All right. Now let's try another one. All right. So now this scenario is on a school excursion, and you have Fred and Sam. I'll give you a moment, read over the dialogue, and see what you can work out. And start thinking about, there's an idea of a set here. All right, can you find this? There is a set of big cats in a zoo who have the property of eating meat. You see, Sam is threatening Fred, you know. If he keep being a smart ass, you know, what will happen? Okay, let's try another one. The scenario is in a discussion in the class on the topic of careers. All right, I'll give you a moment to go over the dialogue. All right, so here, Fred say he wants to become a politician, and the teacher cry out, really? Do you really want to go to camera and hang around those big mouth who argue all day? So there is an idea of a set somewhere here, right? Okay, so there is a set of politicians in camera who have the property of arguing a lot. All right, so the next things I want to talk about is, how do you determine if something new that you see belongs to a set? Now, grouping is a very basic operation in a human mind. But how do you decide if something new that you see belongs to a certain set? Okay, you need to look at the properties of the item. Okay, now let's look at an example. How do you decide if a bird is a duck? Well, we all know, you know, a duck would have some properties like web feet for swimming, the quacking sound, the feathers, you know, waterproof, so it won't get wet, and the shape of the beak and what they use it for. And the duck can also fly, you know, that sort of thing. All right, so now we look at a picture. Here we see some animals, and we look at the feet, we look at the wing, we look at their habitat, and you look at them. Would you agree they are ducks? I think so. So yes, they are ducks. So in this case, you can put these animals into a set of ducks. Let's look at another picture. Here we have some other birds. Look at the feet and look at where they are. Do they look like ducks? Probably not. You know what they are. So no, they are not ducks. So these animals you can't put into the set of ducks. Well, so it's all well, talking about the idea of a set and, grouping, and things like that. But what does all that has anything to do with mathematics and thinking skill? The truth is, there's a lot to do with this. Okay, let's look at an example. Here we have two students. James like math, Jim and art. Ken like science, reading, art, and math. Now, so we'll use the idea of set to organize the information. Okay, so first we have a set and we call it set A. And that's for James. All right, so math, Jim, and art. And the property for the organization is being liked by James. Okay, so we'll do a similar thing for Ken. So we have set B, and we put science, reading, art, and math in it. And the property is being liked by Ken. Now, you can further process the information and organize further. For example, you can see that James and Ken, they do some subject together, you see. So math and art can also do math and art. So you can actually show the intersection, the overlapping between the two. So here we have a diagram of the two sets, the overlap. And the two subjects that they do together is put into the middle, the overlap. And then for set A, for James, we put James of that, and science and reading. So this is, a typical graph that you hear people talk about, the Venn diagram. Now, what actually happened here? This is a part of the process of human thinking where information is converted into knowledge. Now, this is really important. Now, it's not that I'm trying to make a philosopher out of you, but this is what it is. And when you go to university, that's what they will be talking about, the conversion of the information into knowledge. Okay, so how is the organization of information useful? Now, so from the example, you can see I have organized into a Venn diagram. Now, in this case, it's just two sets overlapping. Well, it can help you to answer many questions. Now, let's explore it. Now, the first question is, what subject both Ken and James will do together? Well, the diagram shows you very clearly they will do art and math together. What subject does James not like? Well, James like math, gym, and art. Science and reading is not part of set A. So the answer is that James doesn't like science and reading. Now, what subject Ken does not like? Now, Ken like science, reading, art, and math. Jim is not part of it, so he doesn't like Jim. What subject Ken and James can share notes? So the idea that if they go to the class together on the same subject, they can share their notes. So clearly, the diagram shows you that they can share notes in art and math. Okay, how about how many subjects are offered to the student? Okay, how many different subjects? Now, if you have look at them, you can count them. So gym, art, math, science, and reading. So 5 subjects altogether. Now, you can see that once the information has been converted into knowledge, now you can see once the information has been converted into knowledge, you can make better sense out of the information and you can make many conclusions. Now, the next thing I'm going to talk about is the very basic operation that you do with set. Now, the first operation, the most basic one, is called union. So what is it? Now, look at the example. So we have set A, math, gym, and art, and you have set B, science, reading, art, and math. Union is the action of combining 2 or more sets. In this case, a very simple case, you have 2 sets. Now, we'll see how we combine these 2 into a bigger set. All right, so we're going to create a set C, which is the union of set A and B. Now, if you're curious what they do out there at a higher level, you go to university or whatever, then you will see that they will write like this. So they will see C equal to A union with B. So you sort of get the U there in the middle to show that A united with B, right? And that will give you C. So what do? First, we collect all the members of A and B and we put into C. And then we need to cross out what is repeated. So we cross out art because the art appeared twice. And we cross out math because the math appeared twice. So that's it. So we end up with a set with 5 items. So now we have math, gym, art, science, and reading. So set C is a union of the 2 sets. All right, let's have a look at the next operation, intersection. So same example, we have 2 sets A and B. The intersection of 2 or more sets is simply the overlapping of the sets. Okay, so here we draw up a picture of 2 sets overlapping each other. Now, the next thing is we find what share between the 2 and put into the middle. Then the rest will go in. Now, you see, so the bit at the middle here becomes set C. And in set C, you have 2 elements. So you have math and art. Yeah. So the intersection, right? So the formal way people write it is something like this. C equal to A intersection with B. Now, again, you don't see that symbol, unless you take a formal, course. And you probably don't even do it until you go to university. All right, so there are other operations as well. Now, the strange thing is that students need to do all these things, but they never get taught. So you go to the selective school test, you go to scholarship test, they get you to do these things in your mind, and they assume that you just know. So you don't get taught. Yeah, that is a bit of a problem, isn't it? But you're lucky now that I actually talk about all this and take you through all this. So here we have 2 sets again, okay? Now, first, we will look at the difference between the two sets. This is a bit like the difference can be A take away B or B take away A. Now be careful. The two actually give you different results. Yeah. So the difference is something you have to be careful. Now, in the case of A take away B, look at it. Look at what share between A and B. So you take away what inside B that also appear in A. So you get a set C, and let's write A into it. So here you have mass, gene, and art. Now look at B. Now you find art in B. So yep, take away, that go. Now you see mass, take away, that go. So that's it. C is the difference when you do A take away B. But if you do the other way, now this time if you look at B take away A, now you have to start with set B. So science, reading, art, and math. Now everything you see in A that also appear in B, you have to take that away. So math, we take that away. Art, we take that away. So the difference, B take away A, give you the set C that have science and reading. All right, the next one is called complement. The complement of a set is a set of all the other items not in it. Now, this is a bit tricky, isn't it? This is a set of all the other items not in it. Now, can you see you really need to know what the other items are? Yeah. So how do you find, for example, how do you find the complement of A? Well, I'll tell you what. You have to do the union of the two sets to get all the items. After that, you can compare with A. And then you find what not in A. So first, we have to do the union. So the union of the two sets, as you have seen before, is something like this. So you have mass, gene, art, science, and reading. Now, remember, the union, you put all together, then you need to cross out what repeated. So now the union give you 5 items. And then you can do the complement of A by crossing out whatever you see in A. So cross out the mass, cross out the gene, and cross out the art. So the complement set for A is reading and science. Now, if you try to get the complement of B, you do exactly the same thing. You find the union of the two, and then you cross out everything that you see in B. Yeah. In that case, if you cross out everything you see in B, and then the complement set for B will be just gene, just one item. Now, subset. Subset is a smaller set that has some elements in the bigger set. So if you take set A, all right, so take set A, so we have math, gym, and art. Now, a subset of A could be just math, or it could be math and gym, or it could be just gym, or it could be just art. So it's just a smaller set. The idea of a superset is a bigger set that has all the elements in a smaller set. So if you take any set and if you add any more item into it, that will become a bigger set, and that will be a superset. Now, in this case, if you want to have a superset of both A and B, guess what it is? You already know what it is. It's a union of the two. So if you put math, gym, art, science, and reading together to make a set C, C will be a superset of both A and B. Now, this is something you probably already know, a Venn diagram. You hear about it, but by now, after you have gone through with me, now you know that a Venn diagram is based on the idea of sets. Okay, a Venn diagram is a visual representation of the relationship between different groups or sets of data. It often consists of overlapping circles or other shapes, with each circle representing a different set and the overlapping area between the sets. So most of the time, people will draw circles, but this is okay. You know, if you want to draw a square or rectangle or whatever, it doesn't matter. Okay, so let's look at an example. Now, here is a Venn diagram for a survey. And in it, each of the stars you see in there stand for one student who owns at least one pet. So imagine the whole process. Some students have done a survey over a group of students and asked questions about how many pets and the type of the pets. And the student get the information and then organize the information into sets and build a Venn diagram. So this is the product of the process of converting information into knowledge. So now you have the diagram. Now this thing can help you answer many questions, okay? So let's have a look at some of the questions that the diagram can help you to answer. Now, the first question is, how many students are there? Now, can you actually answer that? Now, read the question again. Each of the stars in the Venn diagram stand for one student who owns at least one pet. So, yeah, this question is easy, isn't it? All you need to do is to do the counting of the stars. So, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There we are. We have 10 students. So yeah, this question can be answered. How many pets are owned by the student? Now, can you answer this question? Think about it. It's actually hard, maybe impossible, because it says that stand for one student who owns at least one pet. So let's imagine that a student who say that I have dog at home. Now, it say at least one pet. So what happens if the student have 20 dogs at home? No. You say you cannot answer this question. So how many pets owned by the student? You cannot answer this question. No, you can't answer the question at all, right? All right, let's have a look at the next question. So, what is the minimum number of pets owned by the student? Now, is it possible to answer this question? I think it is, because we're talking about the minimum number. Now, well, obviously, the smallest number of pets a student can own is just one pet, right? So in this case, yes, you should be able to answer this question, assuming that each student will own just one pet. But be careful here, because the diagram show you that some students actually own dog and cat. Some even own, dog and bird. And some own bird and cat. Yeah, so be careful here. So what would be the minimum number of pets? So here we have 1, 2, 3, 4, 5. Now, the intersection will be interesting. So that one will have 2 there. Now that one will have minimum 2 there because you have a bird and a cat. And that one will have 3 as the minimum because the student can have a bird, a cat, and a dog. All right. Now, look out here. We are not sure what type of animal, but we know 2 students. And minimum, you get 1 each. All right. So now you'll be able to add them all together. So 1, 2, 3, 4, 5, 6, 7. Add 2, we got 9. Add 2 with 11. And add 3, we get 14. So yes. Yeah. So you have 14. So yeah, the minimum will be 14 pets. How many different types of pets are there? Now, this one is easier to answer. We know bird, dog, and cat. The 2 out here, we don't know. Assume. Oh, no. How many different types of pet? The 2 out there, we don't know whether the same pet or 2 different pets. So that means no, you can't answer that question. How many different types of pets are there? Now, what could be the maximum number of pet type? Now, I think this one we can answer because we have dog, cat, and bird as the 3. Now, the two pet that we don't know out there, if we assume that they are different type, then we add 2 more type. So the maximum number of pet type will be 5 pets type. Okay, so that we can answer. So 5 pet type. Now, what type of pet is a favorite among the student? This means that you get this type of pet will have the highest count, among all the students surveyed. So look at the thing clearly. The dog. Dog have 1, 2, 3, 4, 5. 5 students actually own the dog. So yes, the dog. Okay, so that easy to answer. Now, how many students have both cat and dog in the house? That also easy. The intersection between the 2 set cat and dog give you 2. So the answer is 2. 2 students. What is the maximum number of pets inside a house? Can you answer that question? What is the maximum number of pets inside a house? Well, the question say who own at least 1 pet, and it doesn't say how many is the maximum. So no, you can't answer that. What happens if a crazy guy, own 20 dogs or maybe 50 dogs? No, you can't answer that question. Now, you can make a mistake here. You think about the house that have all 3, dog, bird, and cat, and you think about number 3. No, that's not right, because the person may have many dogs and many birds and many cats, so you can't have that. Okay, the next question is, what is the maximum number of pet type in a house? The maximum number of pet types in a house. Yes, you can answer that. One of the kids actually have all three different pets, dog, bird, and cat, right here. Right, so the maximum number of pet type in a house is going to be three. How many students only like dogs and nothing else, just dogs? So here we can see the three there. So there are three students who only like dogs, three. Now, can you see when you have a Venn diagram, which is the result of the organization of the information? It helps you to answer many other questions. So the information is surveyed, collected, organized, and then you can infer from the information, make the conclusion, and answer so many questions. Now, this takes to the idea of the thinking process. Now, I have been talking about that. So by now, you know what it is. So the first step is you collect the information. The next step, you organize the information to create knowledge. And then after that, you can use the knowledge to make useful conclusions. You can answer questions. All right, so yeah, congratulations. I mean, you have gone through the basic theory about sets. Okay, so how is all this useful for you? Well, this information, this is sort of skill and knowledge will help you to solve many problems. Now, let's have a look at a math problem. We have 12 people in a room. 6 people are wearing socks. 4 people are wearing shoes. 3 people are wearing boot. How many people are in bare feet? Okay, now to solve this, all we need to do is to group the information and build a Venn diagram. Okay, so we have 12 in a room, 6 wearing socks, 4 are wearing shoes, 3 are wearing boot. So important you put the 3 wearing boot, and we have socks, label the set properly, and shoes. Now, all right, 6 wearing socks, but you already got 3 at the middle, sharing already 3. So you take 3 away from 6, you get another 3. So 3 plus 3 give you 6 people wearing socks. And 4 people wearing shoes, you get 3 at the middle already, so only 1 just shoe without socks. And how many people are in bare feet? So far you accounted for 7 people already. Now you got 12 people in the room. So you got 12, take away 7, you get a 5. All right. So there'll be 5 people outside. So the answer is that you have 5 people in bare feet. Let's have a look at another problem. All right. In the survey, we have 80 students. And they were asked if they like vanilla or chocolate cake. All right, so we get the information there. 35 students like a vanilla, 32 like chocolate, and 24 say didn't like either of them. Okay, so how many students said they like both vanilla and chocolate? Yeah, the bit on the middle, isn't it? Okay, so let's build a Venn diagram. All right, so we'll have a circle, and we have another one. Okay. Now, we need to label them. So vanilla and chocolate. There we are. Okay, now, we know we have 80 students. We know 35 students like a vanilla, so we put 35 here. So we know a vanilla 35. Now chocolate, we have 32 there. Okay, we know that. And 24 said they didn't like either vanilla or chocolate. So you got 24 out there. Okay, so you know that if 24 outside the circles, so how many actually go inside the two circles? So now, so you can do 80, take away 24. Now, so that is going to be equal to 56. So we know that 56 of the student will have to go into the two circle. Now, it's become tricky. To work it out, you really need to get what go into the middle. Yeah, that's the first bit. How many students actually like vanilla and chocolate together, at the same time? Now, the way to find that is to look at, we have 35 students like vanilla. You got 32 students like chocolate. Now, if you add the two numbers, so you get 35 plus with 32, you got 67. Now, can you see 67 turned out to be too many? Because the 67 is higher than the 56 student that's supposed to go into the two circle. So why is that? Because of the double counting. When you count for vanilla, you count the section at the middle there too. And when you count your chocolate, you also count that as well. So you need to get rid of the double counting. Now, how do you do that? Okay. Now, the way you do that is you take 67, you take away the real number of students, which is 56, you got 11. Now, that is actually the double counting. So 11 students go into the middle. When you overlap, you double count. All right, so you know 11 go into the middle. So how many will go to only a vanilla? Now, to do that, you take 35 for vanilla, you take away the middle. Then you got 24. So you got 24 only like vanilla. Similar, you do that for chocolate. So you got 32, take away 11. So you got 21. So 21 go to chocolate only. So now you have successfully built the entire Venn diagram. Now, how many students said they like both vanilla and chocolate? Actually, we have overdone it. We already got the answer right here. The bit go into the middle. They like both? Yeah. So yeah, the answer is 11. We don't have to do the extra bit. But if the question asks about many other things, you would have to create the entire Venn diagram. Okay, so we have seen an example of math that involve sets. Okay, so now let's have a look at the thinking skill. In the selective test, you expect to have thinking skill questions, and some of the questions will be based on sets. Let's have a look how the knowledge and the skill you have learned in set theory is going to help you. All right, now let's read the question. Now, so all German speakers speak Italian. All Italian speakers ride bicycle. Which of the following statement must be true? And you have the choices. All Italian speakers speak German. All bicycle riders speak German. All German speakers ride bicycle. All Italian speakers who ride bicycle are German speakers. Very confusing. Now, if you try to just reason this in your mind, it will pretty bad. How are you going to figure that out? Now, this is where your knowledge of set is going to give you the magic. All right. So we need to put these different people into groups. And that's how it works. So let's look at the first statement. The first statement say, all German speakers speak Italian. Now, all of the German speakers speak Italian. That means some of the people speak Italian don't speak German. You see that? So that means the set of Italian speakers should be bigger. So the idea is like this. You have a set. Now this set, we have the German speakers. Now all of them speak Italian, but some who speak Italian don't speak German. So that means that the set of Italian speakers is going to be bigger. This is a superset. It's actually outside. So that is Italian speakers. Yeah. So the first statement you see there has been coded into the diagram. Now, then it say all of Italian speakers ride bicycle. So that means some of the bicycle riders are not Italian. That means it's a bigger set again. So yeah, we need another set. So okay, so we need a bigger set again. Okay. Now that set there are the, well, give me a moment. They are bicycle rider. Okay, so now we have the complete pictures and we can use that. Now let's check the choices. Now, all Italian speakers speak German. Okay, all the Italian speakers speak German. How about those here outside the small circle? No, they don't speak German. They only speak Italian. See? So no, that's wrong. So that means that A is wrong. Now, all bicycle riders speak German. No, the bicycle rider out here and here, they don't speak German. No, they don't, okay? So that's wrong. No, all German speakers ride bicycle. So all the German speaker in here, inside the small set in here, they ride bicycle. Yes, that's true, because that is a subset of the bicycle riders. So yeah, we have got the answers. Now, the last choice, all Italian speakers who ride bicycle are German speaker. No, the Italian speaker could be here. And they ride bicycle, but they don't speak German, so D is wrong. Yeah, so C is the right answer. Now you see, the knowledge of set really help you to solve the problem easily. Now let's have a look at another one. Thinking skill question again. Everyone who like math like science. Now similar to what you have seen before. Now we have math, science, and English here. So let's draw a little set first. Okay. So everyone who like math like science. So that suggests that this is math here. Okay. Now, this is going to be the subset of science. So we have science here. So the first statement gives you that picture. So math is a subset of science. Now, some people who like science also like English, only some. but no one like both English and math. So there's no overlap between English and math. So yeah, we know how to draw it now. So here we have a circle there, and that will be English. Now, there were more people who like science than those who like English. Now, the drawing actually look good because the circle for science is really big. It showed that, more people like science than English. So that's look right. And then it's like all the people who enjoy history, all the people who also like math. So that means the history must be a subset inside math. Okay. So now here, we have history here. Now, history is going to be inside math. Okay, now we have the whole thing. Now that should be good enough for us to solve the problem. So what was the most popular subject? Now clearly, look at the thing. Science is the most popular because history is smaller than math, math is smaller than science, and English in the text is smaller than science. So the answer is D. There you are. Now, can you see? Set theory really help you to solve all these problems. Now, it's your turn to solve some problem. Now, what I suggest is that you get a piece of paper and a pen, and you will use the skill that you have learned and create Venn diagram, or, just diagram of sets to help you to solve the problem. All right, I'm not going to solve this, but I give you the answer. And yeah, you just try to solve it and make sure you get the right answer. Now, so the correct answer for this question is 29. So draw the Venn diagram, work it out, and if you get 29, you get it right. Now, let's look at the next question. Again, I'm not going to solve this question. This is a thinking skill kind of question. And you will go through the same process. You will draw the sets. And from the set, you will go to the choices A, B, C, D, and check to see which of the choice is the correct one. I'll give you the correct answer. And if you get it, after you have done your drawing, you would get it right. So the correct answer is D. Okay, thank you for watching, guys. Hopefully, this video really helped you to get prepared so that you can deal with some of the questions that you will see in the selective school test and a scholarship test.